Hey guys, welcome to my class Python for Beginners, and this is lecture number 15. Today we're going to start studying object-oriented programming. So up to now, most of the programs we have been writing use a procedural programming paradigm. In the procedural programming, the focus is on writing functions or procedures which operate on data. In the object-oriented programming, the focus is on the creation of objects which contain both data and functionality together. An object-oriented program will usually contain different types of objects, each type corresponding to a particular kind of complex data to be managed, or perhaps to a real-world object or concept such as a bank account. A program might well contain multiple copies of each type of object, one for each of the real-world objects the program is dealing with. For instance, there could be one bank account object for each real bank account at a particular bank. Each copy of the bank account object would be alike in the methods it offers for manipulating or reading its data. But the data inside the object would differ, reflecting the different history of each account. So rather than explaining you everything theoretically, let's actually dive in to implement a class and see how things fit together. Now consider the concept of a mathematical point. In two dimensions, a point is two numbers or coordinates that are treated collectively as a single point. Points are often written in parentheses with a comma separating the coordinates. For example, in the parentheses you can have a 0, 0 representing the origin and an x, y within the parentheses to represent the point, x units to the right and y units up from the origin. Some of the typical operations that one associates with points might be calculating the distance of a point from the origin or from another point, or finding a midpoint of 2 points, or asking if a point falls within a given rectangle or a circle. We'll shortly see how we can organize these together with the data. Now one way to do this is to use a tuple. For example, we say that point P, let the shell load. Okay, let the point P be a tuple x 5, 3. Alright, so now this is a point for you. Another way is to have a class. Now let's actually open a file and start writing our class. Alright, so this is lecture number 15. Alright, so let's say we have a class with the name point. A class point is a collection of point objects. So now I'm going to introduce you something called a docstring. So docstring is usually the first statement following a function or a class and things like that. So I write here point class represents and manipulates xy coordinates. Now what advantages does a docstring have? So for example, on the shell, let's write a function multiply. Takes two integers a and b, and now we write a docstring that says what the function actually does. Returns the multiplication of two integers. Alright, okay, now we are done. A times b. So I'm done here. When I'm trying to call this function on some point, let's say, and just as I start to open the bracket, open the parenthesis, it tells me that it takes two arguments and returns a multiplication of two integers. This is the docstring which is recognized by various tools. this is the advantage. Okay, let's move on to our class. And now the first function in a class we're going to write is the init function. So there's a special way to write this function: double underscores init double underscores, then on the parameter self. So let's write create a new point at the origin. We write self.x is equal to 0, and self.y is also equal to 0, and that's it. So we have done declaring our class and creating the first method in the class. So every class should have a method with this special name init, followed and preceded by underscores, double underscores. So this initializer method is automatically called whenever a new instance of point is created. It gives the programmer the opportunity to set up the attributes required within the new instance by giving them their initial values. The self parameter, we could choose any other name, but self is the convention, is automatically set to reference the newly created object that needs to be initialized. For example, let's have a point P, and we try to, so P right now is just a variable, and now we say the point P, I want to create I'll create a point P. So this is the constructor method with the same name as the name of the class, and I declare and I call this, and Q is another point. Okay, now we have constructed our 2 point objects. So now if you want to print the x and the y coordinates of these points, you can say I want to print p.x, p.y, and q.x, q.y. Let's see what happens. We have 5. Okay, so embarrassing. Okay, 0 0 and 0 0. So each point object has its own x and y, so you don't need to bother about these x and y's. The program will not get confused over these x and y's, because these x and y's refer to the points x and y's. So this x and y refers to p's x and y. X and y are just the attributes of the point object, and these attributes happen to be the coordinates in our case. So the variables p and q are assigned references to 2 new point objects. So p and q, when you set p's point, so it creates a point object, and p now points to this object. A function like point that creates a new object instance is called a constructor, and every class automatically provides a constructor function which is named the same as the class. This is the automatic function provided by Python, and this has the same name as the name of the class. Okay, so it may be helpful to think of a class as a factory for making objects. The class itself isn't an instance of a point, but it contains the machinery to make point instances. Every time we call the constructor, we are asking the factory to make us a new object. As the object comes off the production line, its initialization method is executed to get the object properly set up with its factory default settings. Okay, let's come to attributes now. So like real world objects, object instances have both attributes and methods. We can modify the attributes in an instance using the dot notation. For example, now I want to change the coordinates of the point P. So I say p.x is 4 and p.y is 5. So now if I want to print P, this is, I know why my computer is slow today. Initially it was 0 0 and now it's 4 and 5. So the expression p dot x means go to the object p refers to and get the value of x. You can either print the value or set the value. Now a better initialization would be to change the init method itself and take optional arguments. So let's say so what I did here is setting these values. This means that the construction function, which itself calls the init, takes two optional arguments. If you provide something, then it takes the provided values x and y. If you don't provide anything, these two become the default values. And now as I want to say, self.x is x and self.y is y. So you don't need to actually get confused between these two x's, because self.x will set the value of the attribute x of the object that self is pointing to, which is set to the value x, and this x is this x. Okay. Now what you can do is create a new point at the point x comma y, and now you can actually call point p and initialize it to values 3 and 4 and the point q with 5 and 6. Now it might be printed and you get 3, 4 and 5, 6 as the values of p and q. So now we come to adding other methods to our class. The key advantage of using a class like point rather than a simple tuple which we used earlier now becomes apparent. We can add methods to the point class that are sensible operations for points, but which may not be appropriate for other tuples, like a tuple 2512, which might represent, say, a day and a month, example Christmas Day. So being able to calculate the distance from the origin is sensible for points but not for the tuple day and month. For day and month data, we'd like different operations, perhaps to find what day of the week it will fall on in the year 2015. Creating a class like point brings an exceptional amount of organizational power to our programs and to our thinking. We can group together the sensible operations and the kind of data they apply to, and each instance of the class can have its own state. So let's try to define a new function in our class that operates on a point and tells you the distance of that point from the origin. So this is distance from origin, and so I want to tell you something about the self as well. So when you say self, you don't actually pass anything as an argument to this function distance from origin. You call the function like p dot distance from origin. So when you say p dot distance from origin, the self parameter defaults to the value of p. So p was referring to the object, and now you call a method on that object using p dot something, p dot method. The self parameter also now points to the object as the same as the object p was pointed to. So inside the function defined in a class, you always say self dot something, and self now references the object on which the particular function was called. Example, here you can just return the square root of something, this something happens to be self dot x whole square plus self dot y whole square, self dot x whole square plus self dot y whole square, and you take the square root of this thing. Alright. So now let's say I want p dot distance from origin, this. I want to print this distance. Here we have 5. The point is 3, 4. So the distance of the origin is 5. It's 3 square plus 4 square under root, and it is 5. Notice that the caller of distance from origin does not explicitly supply an argument to match the self parameter. This is done for us behind our back. Exactly what I was telling you a little while earlier. So now let's come to the topic of instances as arguments and parameters. So we can pass an object as an argument to a function in the usual way. For example, I want to write this function def print point. It takes a point object, the instance of a point class, and it prints out point dot x and point dot y. And now I want to call print point on point p. Okay, so we get 3, 4. Now most object-oriented programmers probably would not do what we have just done in print point. When we are working with classes and objects, a preferred alternative is to add a new method to the class. For example, let's add the method toString, and since it will be invoked on some point, we just pass the parameter self here, and I want to return self.x and self.y. And now I want to call p dot, I want to print p dot toString, and that's what I get. And I get a 3, 4. Now, but don't you think we already have a string type converter that can turn our object into a string? We learned about it, right? Yes. And it doesn't it print automatically? Doesn't the print function use this for printing things? It does. But these automatic mechanisms do not yet do exactly what we want. For example, instead of the print, I want to say strp. If I hit F5, it says some sort of gibberish. I don't know. I'll print str. And it just says that p is a point instance. Well, that's not exactly what we wanted. We wanted to know the values, so the attributes of the point object are. So Python has a clever trick To fix this, if we call our new method just str instead of toString, the Python interpreter will use our code whenever it needs to convert a point to a string. For example, so instead of toString, I want to call my function str. Again, the same way the init function is written, with two underscores preceding and following the function name. And now I return self.x and self.y. Now if I try to print str t or rather, oops, I'm sorry, now you can actually just say print t and string returned a non-string type. Oops, sorry guys, I think we will have to return a string. Okay, my bad guys. Okay, let's say x is %s, x is %x and y is actually t, and this. Now let's see what happens. X is 3 and y is 4. So now we declare a string function, the str function, applied it on a point. Let's see what happens if we do str point. Just want to check this again. Just want to be sure what happens when you string. Okay, so try to print str and the same thing. So now when we call the string str on the point p, this function is invoked and it returns this string for you, and this string I have written in the form of the format and the value sort of strings I taught you. So I want to return this string where x is %d and y is %d, and these are self.x and self.y respectively. Okay. So functions and methods can also return instances. For example, we are given 2 points. You want to find out their midpoint. You can write a regular function for it. Example, you write the function def midpoint, and it takes 2 points p1 and p2 and returns, or rather let's say the new point has new x is equal to p1 dot x plus p1 dot p2 p2 dot x over 2, and y is same thing but with the y's, p1 dot y and p2 dot y by 2. Now I want to return a new midpoint object, so what I do is I just return point. See the use of the doc strings there. Okay, and x and y. This is the new point I'm returning. So now you can say outside of your code that r is equal to the midpoint of p and q, and you want to print r. So x is 4. Okay, just wait up guys, there's another p here. Okay, let me just comment out this thing. Okay, x is 4 and y is 5, so 3 plus 5 by 2 and 4 plus 6 by 2. So this is our new midpoint. So let us do this. Now we can also do this as a method. And suppose we have a point object and we wish to find the midpoint half between it and some other target point. For example, I declare a function def halfway between self and a target point. So I say mx is now self dot x plus target dot x. This whole thing divided by 2. I'm putting the parenthesis. I guess you know why. And my is self dot y plus target dot y over 2. Okay. And now in the same way as before, I just return a point mx and my. To invoke this, we can now just say our new point is halfway between p, so p is the self, speed dot halfway, see nothing, okay, p or halfway of q. In the halfway of p and q, I'm invoking this on p and it's between p and q. Similarly, you can invoke it by saying q dot halfway of p. Now you can print p and you most likely get the same thing, and you actually got 3. And what is this printing? Oh my god, I've actually printed p. Sorry guys. Now if you print out x is 4 and y is 5. The last thing is that these things are also composable like functions. So we can say that you can write it in one line, that point 3, 4 dot halfway point 5, 12, 5, 6, and close this. Now if you hit F5, get x is 4 and y is 5. So guys, this is the first class on the topic of classes and objects. I'll see you with more examples of how to use classes and objects in the next class. Stick around and keep up the hard work. Take care.